All right, so this section is dealing with square roots in the denominator. Okay, and how to get rid of those. And so when we do this, we have to get rid of the root in the denominator. So if there's a root in the numerator, we actually, other than the fact if it needs to be simplified, we kind of don't care. So like this root here, this is root 9 and root 6 over 6. So this is 3 root 6 over 6. And remember, we only reduce outside of the root. So that is 1/2 root 6. So root 6 over 2. But sometimes we end up with roots in the denominator, which you'll see in a second. But again, here, roots in the numerator, all I care about is simplifying my roots out. So I have 6 minus 2 root 6 over 12. And then remember, if we have a 12 in the denominator, whatever I divide by has to go to both terms. And so when I divide so I can divide everybody by 2. So that becomes a 3, that goes away, and this becomes a 6. So that's 3 minus root 6 over 6. Okay. Here, I'm going to go ahead and simplify these separately. I don't know why I drew the little, looks like little beaks. Let's get rid of that. So root 27 is root 9 and root 3, and then root 75 is 25 and root 3. So those root 3's cancel out, strangely enough, and I get 3 over 5. Okay, so now if I have them square rooted separately, I can actually, if I wanted to, write this as one big square root. And I can simplify the fraction first. So I can reduce my 6 and my 2 and get 3. And then rules of exponents tell me that I can, subtract my exponents. So this would give me a square root of 3y to the 4th. Which is y squared and a root 3. So y squared root 3 is my answer. So I can always split them up like this. That would be how it was originally split up. Or I can write it as one square root. Okay. Now, my pages are out of order, so I got to flip through the problem set for a second so that I can find my next examples because they're like buried somewhere. Okay, so like this, they have the square roots separate. So I can rewrite this as one big, huge square root, 147 ab to the 8th over 3a cubed b to the 4th. And I can simplify. So 147 divided by 3 is 4, 12, 27, 9. So I get square root. 49 is going to be in the top. When I go through and my a cubed becomes an a squared in the denominator because I subtract exponents. And then my b to the 8th and b to the 4th, I subtract again and I get a b to the 4th. Okay, so now I can then split them apart. So root 49, root b squared, and a root a squared. So I get a 7b squared over a. Okay. Now, what happens when I do something and my roots don't go away in the denominator? Well, then what I have to do is I have to what we call rationalize the denominator. What I do is I multiply by a fancy 1. So it's whatever that root is in the bottom, provided that there's no addition or subtraction. And I multiply the top and bottom by it. So it gives me a negative 8 root 6 over 3 times square root of 36. So that is negative 8 root 6 and then a 3 times 6, which is 18. So negative 8 root 6 over 18. And then my 8 and my 18 are both divisible by 2. So divisible by 2 gives me 4. Divisible by 2 gives me 9. So this is negative 4 root 6 over 9. Okay. Now what happens when everybody is square rooted, but I can't really simplify anything? I have to split it apart. Okay. And then what I have to do is I have to simplify what I can. So this is root 4 and root 3. So I have a root 5 over 2 root 3. Now I have to get rid of that root in the denominator. So I multiply the top and bottom by the square root of 3. And I do this when there's no addition or subtraction in the denominator. There's just the root by itself. So this gives me root 15 in the numerator and a 2 times the square root of 9 in the denominator. So root 15 over 2 times 3, which is 6. So root 15 over 6. Now what happens if there's an addition or subtraction sign in the denominator with a root? Then what we do is we multiply by 1 still, but what we're trying to do actually is to get rid of it. We're trying to create what we call a difference of squares, right? So similar to when we were doing factoring, we're going to create ourselves a difference of squares, because if we create ourselves a difference of squares, remember, difference of squares is like something squared minus something squared. Well, if I have something squared minus something squared and they're all like there's a square root in there, then the square root and the squared cancel each other out. So that's what we're trying to sort of create. So what we do is I look at the sign in between, in the middle, not in front of the 4. I don't care about what's in front of the 4. I care about what's in the middle of the number and the root, and I switch it. So if it's positive, it becomes negative. If it's negative, it becomes positive. And I multiply the top and bottom by it. Okay. What that does is in the denominator, when I box this out, and you don't have to box this out every single time, because you should be able to recognize what you're doing. 16, 4 root 2, 4 root 2, and a minus root 4, which is negative 2. But what you should notice, right, is that across my diagonal, my roots are actually canceling out, and I'm left with 16 minus 2, which is 14. So my denominator is 14. Now my numerator, I have to take that 3 to both terms, so that's 12 minus 3 root 2. Now, not everybody is divisible by anything, and so I have to just leave it. That 3 root 2 that's here is not even, so I can't do anything with it. So it looks kind of weird, but that's where we are, what we're left with. Okay. Again, if I have roots in the denominator and I can't simplify, whether there's 1 root or 2 roots in there, I still do the same exact thing. I look at the sign in between my root and I switch the sign. So it's negative, so it's a subtraction, so I change it to a positive, and I multiply the top and bottom by it. Okay, what that does in the denominator is it creates me a difference of squares. So root u minus root 6, root u plus root 6, so root u squared, which is just u, and then a negative, oh my goodness, negative root 6u, and then positive root 6u, so those cancel out, and then a minus root 36, which is just negative 6. So in my denominator, I get u minus 6. In my numerator, I get a root 3u, and I get a plus root 6, plus root 18 in the top. Root 18 can simplify, so this is root 3u plus root 9 root 2 over u minus 6. So this is root 3u plus 3 root 2 over u minus 6. Okay, and it's a subtraction sign at the denominator, like they're basically holding hands in the denominator, so you can't actually simplify anything unless you were to have a u minus 6 by itself in the numerator, which in this case you do not. Okay, so that is it for this lesson.